Welcome to the AMIS Pro Better Build Prep webinar. We're very glad to welcome you here today. My name is Chris Binon. Most of you know me, but not everybody though. Thank you for joining us today. We're quite a bit of people, and there is people who are new to AMIS Pro, as well as people who have been, well, veterans in using the technology. Which is very interesting, of course, because we'll try and focus on both. Also, we have a few companies here that are actually making 3D printers or relevant 3D printers for the technology. That will be interesting to look at what we can do together to bring their hardware with well, better to the market or help users applying the technology. So it's going to be an interesting afternoon. Today here with me is Jacques, whom you can always send your technical questions to. I will also at the end try to make some time for the Q&A. And Mariam is also here, who is taking care of our marketing. Thank you. So anyway, what's on for today? As I said, we're going to try to focus a bit on the basics for whoever is new, who is first user of AMIS Pro, and show you a bit what the new possibilities are with the upcoming release 252. But actually, that's just in a few weeks from now. A lot of things are already in the current version. I will mainly try to focus on the demo, and so I'll try to make some time for that. So I'll try to go quickly through the slides. We'll have a look at the pricing of AMIS Pro, and of course, at the end, you'll have some time for your questions. So let's give it a go. The first part is basically what is AMIS Pro and are the basics. Now you can find a lot of that already on our YouTube channel or on the manual, so you can definitely have a start there, although we'll quickly go through the basics here as well today. Now, the first question that we want to answer, the basics of AMIS Pro, is basically the why. Why did we want to make AMIS Pro? Why could you benefit from AMIS Pro? Why could you consider AMIS Pro, of course? And there's a few reasons to that, and we'll try and go through those quickly. First of all, you might want to put more parts in your batch. I think that's a logical one. Although more parts, it's not always better. You can reach too high densities. We all know what the implications are there. So it's not necessarily better if there are more parts, but nevertheless, we want to put or try and put more parts in a batch. Obviously, you want less risk of breaking parts, of overheating, of bad batches coming out, and you want probably to work with an organization which has a scalable support, meaning that you as a customer, as a user, or can be helped at any time. Now, in that sense, good news, I would say, because it's no longer scalable support, it's actually scaling support. We hired somebody new in AMIS Pro. She's going to start July 22, specifically with the goal of supporting our users. So that's already happening as we speak. What else would you want, or why would you consider? That's because you want to spend less time on all this build prep solutions, on the nesting. Maybe you want to find new workflows to work with, and in the end, you also want a user experience, a user interface, which is easy to use. Now, that was the basic setup of AMIS Pro at any time. And basically, that comes down for you as a user to cost per part. Basically, we all want to bring down the cost per part for additive manufacturing, and that has to do with quantity and more parts, of course, but also with quality, because of course, if a part breaks or if a build fails, that's the quality affecting the cost per part in that case. So let's go look a bit deeper into those reasons why AMIS Pro. First of all, well, you want to put in more parts, and we did some benchmarking. We did it before, but it's still valid, and the speeds are still there. In some other software, you got like one iteration fitting 6 parts, and it takes you 1 minute and 40 seconds. We also tried that in AMIS Pro. One iteration fits 8 parts, and it took us less than a minute to get those parts in. A second example is this one with quite a few parts, and we'll actually be looking at a quite similar batch also in the demo, with one iteration reaching 16%, a bit over 16% in 10 minutes. And in many applications, you get one iteration. In AMIS Pro, you can do a lot of iterations. So you can really choose yourself how far you go into the nesting. There we reach with one iteration almost 20%, and that in 2 seconds and 46 hundredths. So that actually means not only a very fast nesting, of course, and a very dense nesting. It's only a starting point to start looking at a workflow that allows you to make better nestings, not only faster or denser nestings, but better nestings. We'll look into that. Now, what you also don't want probably is risk. For example, the risk of collisions or interlockings of parts. In AMIS Pro, with the QNests algorithm in there, basically that's not possible. If there is a collision or an interlocking, it's one which was caused by the user, meaning that you actually positioned parts in a place and locked them in position in a place where they were already colliding with other parts. Now we have solutions for that as well, but so there is no need to check for it anymore. There is no need to check for collisions or interlockings. You also want less risk when it comes to your nesting percentages. And we used to have only this option, we used to have this option to nest to density, basically limiting the search in your nesting solutions. But that one we've considerably improved over the last couple of months. So hang on, I would say we're gonna, of course, mainly look at those solutions. You all know that we can box the small parts at an automatic process, whereby the boxing follows the need and follows the size of the box part, really. Less risk that can also be created, of course, by adding shell and lattice, and we did make that configurable. As most of you know, or as the experienced users already know, we have only one type of lattice, and so far that's been a solution for all our users, for the whole user base, because in the technologies we're aiming at, that's basically what you need, and that also allows us to make it a more simple to use program, let's say. There's also the recover function, which was actually invented or suggested by one of our first users, and allowing you basically to return in the software all the parts that were not fully printed or not printed at all when your printer has broken down. So imagine here in the example that I was showing, if your printer breaks down at 123 millimeter height, you just enter that number there and it returns all the parts that still need to be printed. Now, another reason was the support I was talking about, and the fact that somebody new is coming to the organization to support this and that. But basically, that stems from the fact that AMIS Pro, yes, we are, or AMIS, we are a startup. But on the other hand, we are part of a global group, a hybrid software group, which is a position that many startups envy us for. Because basically, yes, it gives us speed and agility. We can move fast. We can go forward very quickly. But we're assured of this backup of a whole team, a global team, with representation all over the world, and also allows us to get the necessary support off the shelf somewhere if that's actually needed. Lately, we just a couple of weeks ago, we had a customer in the US. And payments from US to Europe are not always, it's not always that easy. So we just took care of it through our US base of hybrid software. So that really helps us also in that sense, scaling quickly. Also, when it comes to support, yes, there is already the YouTube channel. We have the manual, but we're going to expand that with an online Q&A or frequently asked questions sections and an online user forum, because that's about time with the growing amount of users that we have. Now, a bit more generic, why would you, or why can you benefit from AMIS Pro? Well, basically because the whole build preparation might take you less time. That comes through the nesting speed, of course, but also because you don't have to upload or download things. You can go through very quickly, and we really are careful about avoiding unnecessary clicks or allowing for certain shortcuts to make things faster. And of course, you got the shelling lattice boxing, which all is quite a quick process with the 3MF inside AMIS Pro. Now, the workflows part, I will also demonstrate that in the demo, but you can very quickly move on with unplaced parts. You can do last-minute nesting by blocking previously nested parts. You can shift parts, re-nest, etc., without all that taking a lot of time. So basically, all the before also led to reinterpreting our UX, our user experience, or the interface that we made. And I think all the users up to now, they know, well, we try to keep it simple. And of course, there are more and more features coming into it, but still, it's very limited also because we always chose to work only for these 4 technologies, the MJF, SLS, and binder and material jetting technologies, which allows us to, well, basically not have to put too many options in there and keep it rather simple for our users. Now, that was very quickly, in 12 minutes, I see, an overview of what AMIS Pro was already so far. We'll try and look a bit more now into the next set of features that we have been adding in the last 2-3 months. Basically with the same aim. Basically, we also always wanted to focus on this cost per part and how can we help reducing that cost per part for our users. And of course, and those are also the main parts in our software. This is about part preparation, it's about batch preparation, and it's about a workflow as a whole. Now, starting with the first one, with the part preparation, there's a few things added there. First of all, and it sounds like something small, but actually it's really makes life easier. You can now select multiple parts, not only with shift, and so a whole range of parts at the same time, but also with the control or command buttons, so that you can select several parts individually. And then you can rotate those parts all at the same time. So it really makes it easy. Or you can, for example, also cage them, box the parts together, etc. So that makes it really a bit faster. Definitely, if you have a batch with like 100 parts and you need to move 50 of those, it makes it quite faster to have the selection option. You also have the rotation shortcuts. I think that's already widely in use because it's much faster, of course, than entering just the required rotation of a part. So with Alt X, Y, Z, you quickly move the parts around. We got the gizmo coming up. It was foreseen and promised by the beginning of July. It will be there. Unfortunately, it's not going to be shown yet today, but it will be there in the foreseen time. And then last but not least, I would say we have now a connection with Phasio. Phasio, which is an MES ERP system specifically aimed at additive manufacturing, and quite a few of you must have heard about them already. But basically, what we did there as a step one is that we can import directly in a ComSpec format, that is, parts and their individual rotations into AMIS. Now that sounds very easy, but it really makes a difference, because as you import the ComSpec file, you basically already know how many parts you will need. So there's no room for errors anymore, for mistakes, making mistakes there. You have the rotations right, and they will be remembered in Phasio. So the next time you print them, you can reuse those settings. And so that basically really shortens your part prep, your phase one of the build preparation, let's say. We'll come back on that because there's more advantages to the Phasio integration. This one actually, the rotation of the parts was already in. You could rotate the parts or the allowed rotations for parts. You could set that already on a part per part basis, meaning for each part you could indicate if that part could be rotated over X, Y, or Z, or all three, or whatever you wanted. Now, however, we made it even easier by integrating that into the nesting section as well, whereby you can actually rotate all parts over certain, or allow rotation of certain parts over for all parts at the same time. So that's, again, making it faster to have your parts prepared. Now, when we look at the second part, we had the part prep. Now we're looking at the batch prep. There we also improved quite a few things. First of all, by popular request, I would say it's now possible to indicate your priorities. So you can just select the parts that are priority, and these will be nested first, or at least, if possible, the algorithm will make sure that those parts are in first. Secondly, you can clear your batches. Now, also, that's also one of those that doesn't look too big, but it's actually very useful once you start locking parts in place. Because if you start moving around parts and you lock them in position and then you nest, it's very difficult to, well, basically get hold of that one locked part, which might be somewhere in the middle. So you just throw out all the other parts again and leaving only the locked part, so that you can more easily manipulate that. So it's just a very easy shortcut. A bit similar maybe is the lock or unlock all function, whereby you can not just lock one part in place, but lock the whole batch or whatever was what was nested up to that moment in position inside the batch. That makes it, for example, possible to, well, stop halfway your nesting while waiting, I don't know, for an urgent order by one of your customers, or just to check if maybe something else is still coming in, that you can add upon that existing batch at a later stage. So when you're happy with your nesting and you don't want to touch it anymore, just lock it, and then later on you can put parts on top of that if needed. And as said, we got a lot more options now in the nesting quality, in basically allowing your nesting. And that, for a big part, has to do indeed with your maximum density, your layer density, which you can now really control. So your heat or binder spreading, or whatever your cases can really be closely monitored and changed according to your needs. Thirdly, so after the parts and the batches, we also try to improve your workflow with, for example, those priorities, of course, which will help you in your workflow, but also by, adding more printers, or adding the possibility to select a printer from a whole list, which you can populate as you want. We added the STL export, which is mainly for the SLS users, of course, a very important tool. We extended the part list export because basically some of our users are not only using that for the post-processing or for packing purposes or for checks or double checks of what was printed, but some people also use it, for example, to calculate pricing of their parts. And that's why we added quite a few details in that export, or in that list of batched parts. We also we had already the unplaced function and the recover function, which was mentioned before, which remains very important, I think. And we have this Phasio integration because, as said before, it's not just about importing parts and their specific rotations into AMIS with just one click. It's also about, well, sending back to Phasio whatever details there are available on the nesting. So basically, as soon as you nest a batch, you save it as a 3MF and you reopen it into Phasio. Phasio will automatically calculate which parts are in. And so can deduct automatically which parts still have to be printed if it was more than a full batch. And that really makes a difference with your whole workflow. It's really speeding that up significantly, dramatically, I was going to say, but let's keep it at significantly. Basically, it's something we're looking at doing with different systems, of course, but definitely the cooperation with Phasio has been great so far. Last but not least, and I will definitely try and demonstrate that in the coming, let's say, 20 minutes, nesting is not just one operation anymore. Just before we started this webinar, I had an email coming in from one of our users saying like, okay, the nesting in the alternative software took me 1 hour and 10 minutes. In AMIS, it took me 5 seconds. That's, of course, a very nice example. And the difference may not always be that big, but it allows you to start working in a different way. It allows you to nest and experiment with nesting, not just click this nesting button and waiting and hoping for a good result, but nesting and re-nesting and checking how you can improve it. And that is really something that I want to demonstrate to you now. So let's deep dive into the demo. Here we go. Right. I will try and go through 4 different cases today, because there is one thing very important, I think, and we really notice that with our users. Some users are solely focusing on, for example, insoles, printing insoles. Others are having completely different batches every day, and a third one is really busy with medical, with braces, orthotics, etc. And those cases really require a different approach and a different strategy in nesting. And so I'm trying to give a few possibilities here, but still, if you have any questions, we're really eager to start looking together with you at possible solutions for specific cases or very challenging situations. So don't hesitate to ask us. But while we're going through these different situations, I will also try and go from, let's say, an easy batch to more difficult batches. But anyway, let's go. First of all, I will try and nest a CamSpec file, which is basically this export from the Phasio software, from their ERP AMIS system. And you notice immediately so that this CamSpec file contains not only the different parts themselves, but also their quantities, as I indicated, and their specific rotations. So here, I'll just increase the quantity a bit because otherwise we'll have a very slim batch, a very small batch to be added. And there we are. So that's basically shortcutting our process in many ways. You don't have to be busy anymore with all these entering all these details here, and basically you also don't have to worry about allowed rotations anymore, because basically this is the truth. This is what you're going to nest, and this is how you're going to nest it. So let's just click nest here. And it's a bit slow, of course, because at the same time, Zoom and AMIS Pro takes a bit more memory, but basically there we are. That took like 5 or 6 seconds for a nesting density of 15.34%. Now, for many of you, that will be way too high at this nesting density, and we'll start looking into that in the other examples. But this is just to demonstrate that the Phasio integration allows you to move from importing parts to exporting your batch is really a matter of let's say minutes at most. So there we are. This batch is saved. This one can go to the printer and can go back to Phasio for interpretation there. Now, secondly, we're moving to the next batch, and I'm just opening. Oh yeah, there's something perhaps that I should already mention here. Of course, I opened this in a specific batch, but I can just as well, maybe I made a mistake and it needed to be in another batch. Then I can just, and that's quite new, here resize to a new batch or a new printer setting with a different different build box inside. So there we are, and that's what it is. Anyway, so up to the next one. Yeah, not gonna save this for now. I'm gonna look at not today's batch, but tomorrow's batch, and it's more a medical oriented. Now these braces, etc. Quite often, you've all seen this. It's quite big parts, not necessarily bulky or heavy parts, but quite big parts. It's quite well, quite often indeed all the same kind of parts inside, but all a bit different. So that's a kind of batch from which you can expect that the nesting density will never be very high. They don't fit together too well. It's big, but it's not heavy, so you can expect that the nesting density will remain low. Now, in that case, it's and since the batch was prepared, so I'm not looking too much into the parts preparation here. We'll come to that later. But that quite often means that you wouldn't have to worry too much about nesting or too high nesting densities. So then we're looking at a totally different case whereby just pressing nests with a gap distance of 4 millimeter and a wall margin of 2 millimeter will already give you quite a bit of a solution. You did notice that it took a bit longer in this case, maybe like 10 or 12 seconds. But that has to do, of course, with the allowed rotations. So I allowed all parts to be rotated over all axes. Of course, that means that the algorithm has a bit more searching to do. So that's why it does take a bit longer there. Now, as said, with a nesting density of 6.74%, normally any technology can work, and there is not really an option if all parts are this big that you will actually reach a much higher nesting density. Also, in this kind of cases, the nesting density is quite often not really problematic, meaning here it never goes, or just once it goes just above 10%, but only slightly. There's no high peaks in this nesting density, so there's actually no need to go into the full options or the full possibilities that AMIS has to offer in this regard. Now, what some of you might not know yet, and what I sometimes use, is basically you can start zooming here in this nesting density, which basically allows you to put it next to your batch, so that you get a better view a bit of the of where the actual highest density might be, and that you can actually have a better view. Let's zoom in a bit here, a better idea of where any problem might occur. Not the case here. We're having very low nesting densities. So basically, in this case, your nesting might be, again, a very quick process to go through. Okay, so we move on to the next level, a bit more difficult again, and we'll really start with a new batch this time. Also new here is that you'll immediately get the opportunity to select your printer, which has been predefined, of course. We'll look at that a bit later, which also means that you can, for example, immediately create a half batch for yourself, so that if you know, like, okay, today there's only room, or I only have time to create a half batch, you can just click here, the half batch, and start filling that one up. But we'll start with a full one here. So there we are, our empty batch. As most of you know, we work from left to right, because this time I'm not starting from an existing batch through CAMSPEC or through something that was prepared before. I'm really starting from scratch, so I need to work from left to right to go through the AMIS software. So let's start with importing, of course, a number of parts. There we are. I will enter those in there and it starts loading all the parts. As you know, or maybe not, but AMIS does do a check of the parts when importing. At import, the checks are relatively limited, and we will check for if the normals are okay, if there are small holes, things like that, and they might already be repaired. But the larger checkup is actually only done when you start slicing the parts themselves or the batch itself. That we will soon be changing. Soon we will do all those checks upon the import, allowing you, of course, to have a better look at the problems with the parts. Nevertheless, there will always be cases like this one, whereby your part was really just wrong. There was something wrong with it. AMIS can't repair it, or it's impossible to fix it. In which case you will get a warning, of course, but it will not be imported into the batch. So part one now of what we want to do is our part prep. Now, as soon as I click a part, I got here my part properties popping up. As soon as I double click the part, either here or here, I go into the part view and get a close-up view of that specific part. I can also get a section through here, pressing the section option, so you can go through the part to have a better look here. Okay, and then since we didn't work with the imported parts, we have to enter the quantity ourselves. Here, the number of copies. I can rotate the part, I can scale the part, and the rotation, as mentioned before, the easiest is really with the shortcuts with Alt X, Y, Z, which in this case rotates it over 15 degrees angles, but that in the it's a bit in the way here. I have to move this way in the configuration. I can change that angle to any angle you would actually prefer. Back to my parts, this first part, there we are. And then after the scaling, rotation, and copies, you see the part nesting properties. Now, these nesting properties is, of course, something you will also find in the nest section, but here it's part specific. The nesting gap here is set at 0 millimeter, but the generic nesting gap is set at 4 millimeter in this case. It will always take the highest of the two, so no need to worry. It won't be placed next to each other. It will just take the highest of the two. But in this case, with such a small part, there is no need to increase, so I'll just leave it at 0, not touch it, and move on quickly. Also for the allowed axis rotations, I can press here the Z axis that it's allowed to rotate, but I can also, of course, do that, and why not immediately do that for all parts involved in this batch. So now if I go back to my part, it's indicated that I can rotate it. Okay, over to the next part. I can do that by clicking here, or I can use the Alt N for next or Alt P for previous part to go through even faster as I prepare my batch. So I'll move a bit more quickly here. I need 8 copies of this one, nothing specific in this case. Alt N, moving to the next part, I need 12 of those. I wouldn't want to print it like that, so I'm going to move it up 90 degrees. There we are. Alt N to the next part. This one I want to see in detail. Let's have a look. Okay, I don't like the rotation. I'm going to, oh no, I want to rotate it the other way around. There we are. And this one I need 8 copies as well. Over to the next part. And this is an interesting one again. Why? Because it's quite bulky, 10 by 16 centimeters. And as you can see here in the section, it's, well, full. So that's going to either use a lot of ink or binder, or it's going to insert a lot of heat in there. And the customer has allowed me to, well, foresee shelling. So let's do that. Let's put in a shell and let's add, at the same time, a lattice structure. Creating the shell, I will already execute it. It does take a couple of seconds, and basically if you make it a smaller shelling, it will take a bit more time. But nevertheless, I think this is quite a few seconds only. I'll rotate it a bit upwards, and oh yeah, let's have a look at the lattices inside. As mentioned before, All our users at this point are very happy with just one lattice structure. If you would need, for specific reasons, another type of lattice structure, it's something we can discuss, of course, but in most cases, this one would be sufficient, we suppose. I need 4 copies of this one, and since it's so bulky, I'm actually going to increase its nesting gap so that it keeps a bit more distance from all the other parts, not as to not influence anything there in that sense. Next part, I think I need 100 copies of those. Yes, next part, nothing special there, but we're going to rotate it as to keep those dimensions a bit stable. I need 8 of those. Right, this one, probably you're going to want to print it upwards. There we are, like that. It's a very small part. We need another 100, and this one also 100. Good. So we can move through our parts very quickly, and when you're used to this, it's really very quick to go through because you know you don't have to rotate it, or you know you do have to foresee an extra nesting gap, so that goes then quite quickly. Last 2 parts here, those are quite small and fragile, so we're going to box those. Now, boxing for us is considered a nesting operation, so that's why we don't find it in this header, but we'll find it here in the nesting header. I'll click these parts, I will box them, there they are. I can click on the boxed group, and then we get to see this. Now, just as well, I can unbox this and choose multiple parts at the same times and box them together. So that's also an option. And now we got all these small parts boxed together in here. And that's basically it. That's basically going through your parts and do your part preparation before moving on to the next step. And that's obviously your build preparation. Now there, I think, is where it becomes really interesting. So let's just already nest once. As I mentioned before, the nesting itself comes for free. It's quite quickly, so you can just do that to get a first view. And actually, I would in most cases advise, definitely with this kind of build, to just start with a basic nesting to get an overview. Now at 19.42%, that's going to be hard for many technologies to print. Definitely, if we have a look at the densities involved here, going up to 31% with huge gaps going up and down. Now, you could, of course, start making the gap distance higher for all the parts, but that's still not going to solve the density jumps that you're going to get. You could indicate this one as to density, but this doesn't mean that actually the density will be reduced to 11 or about 11%. It just means that the algorithm will start looking for solutions as soon as it reaches 11%. Now, in this case, the first solution is already 19%, so that's a bit hopeless. So let's not use this one. The maximum layer density, that's really going to reduce the density for each layer. So basically what this algorithm does is it fills up the batch until a certain layer, and then I'm really talking about each 100 micron or 80 micron or whatever you're printing at. As soon as a layer reaches this 13% in this case, it will not add any other parts on that layer anymore. So they will be shifted up a bit. And it goes through the process on and on like that, so as to reach this 13% or close to this 13% everywhere. You also notice that I quite often press cancel here before it reaches 100%. Now that's because I'm going through this process. There is no specific need to wait for the latest update or for the best possible update, because we haven't reached an optimal nesting yet. So that's why when it's at like 98%, you can just press cancel, see what comes out, and improve where you want to improve it. If we're having a look at nesting density now, well, that's quite a difference, of course, with what we had before. All close to this 13%, capped at this 13%, with some exceptions. In some cases, it's almost impossible for the algorithm to not go over this 13%, but it's much closer to what we would need. Now, since we're at this point looking at a MGF machine, 14.1%, I know some people who would print at 14.1% and others who totally wouldn't. It's totally up to you to decide. But let's say it's still too high. So then you can either and or further reduce this one, let's say to 11%. And at the same time, because you may have noticed that it's not really using the full width of the build box. So actually that allows us to increase here the gap distance. And I will actually first do that. I will just leave this at 13%, increase the gap distance. We're now having a nesting density of 14.1%. And you will see that the density or the parts will be spread out quite a bit more, but actually the nesting density remains quite high. So it doesn't harm our batch too much. On the contrary, it will actually spread out more the parts. So that's a very good one to use at that point. And I will now repeat it at 11% to see where we get and to see if this is indeed something printable, let's say. Okay, and now since we're close to the end, close to what we want to reach, you might want to give it a bit more time to find even better solutions. But there's well, quite often you can anyway stop after some seconds. It might still find a better solution, and of course, if you want to, you can wait for that one. Final check on the density. Okay, this looks fine. That's it's a go. We're gonna print this one. So basically, we're gonna move on to the slicing here. Slicing or exporting, depending, of course, on the technology. In general, we have the 3MF export specifically for the HPMGFs. But note, however, that in just a couple of weeks' time also, we will be having the direct HPMGF connection there. So there will be no need to go through the HP Build Manager anymore. You will be able to talk directly to the printer and send your batch immediately to the HPMGFs. At first, there will be the 5000 series, followed by the 4000 series that will be implemented. STL, of course, at this moment, mainly for the SLS technologies. Note there that we're, of course, looking into the different file formats for these SLS technologies, because we know some of our users are waiting for that, really need that actually to move on, because the hassle with going through another step is contrary to what we, of course, want to achieve with AMIS. And then there's also, if you want to slice, typically for the material jetting, binder jetting users, you can slice as TIFF or SVG and export it that way. Of course, you also have the slice preview here to go through if you want to have a final check, let's say, if you want to go through. And we have an improved part list. I'll just save it on my desktop here, which is a CSV file, which is then not only giving you and I will, of course, you can open that in just an Excel file, but it will not only give you the dimensions of the part name, the number, the quantity of the parts that are inside your batch, but it will also give you the surface of each part, and then the box volume, the solid volume, and the printed volume, in case there is a lattice or a shelling inside. Of course, there's a difference between the solid volume and the printed volume. So those are the main options here to go through, with again the direct MGF connections in just a couple of weeks' time from now. Good. Okay, we're very happy this one is batched, but we still have a lot of stuff standing here, which basically we have to do something with. So in that case, we use the unplaced function. Just press unplaced here, and all the parts that were inside the batch, which we previously saved, of course, are thrown away, let's say, allowing you with the same nesting settings to just continue working on this one. Now, in this case, this might be, again, the batch for the day after, but it's not really full. So we can just add a few more parts here. There we are. For example, this one. Let's make that 100 of those and nest again, just to have another demonstration here. First of all, there we are. Our first iteration probably will give some jumping up and down in density, basically because of the specificity of those parts here. Now, that one, again, because I wanted to make it more difficult, let's say, there is another possibility to solve that. Now, first of all, and I didn't demonstrate it, let's make this one a priority. So basically, that will put all the parts in first. So in this case, it will put them below, or rather below if possible. There we are. Let's stop it here, but not really solving our problem. You do see, however, that the parts are rotated so as to fit nicely together in order to not to increase this layer density too much there, but we still have a bit of jumps there. Now, in case I just let it run like this with no maximum layer density, that will make it in a sense, of course, worse in these jumps here going up to 36%. And then there might be another couple of tricks that you might use. Definitely for big bulky parts, you might actually want to move one or two or three of those parts a little bit up. So I now picked one part here. I can change the Z position a little bit so it goes up a bit. And now, of course, we have not an interlocking here, but a collision there. But I don't care because I'm just going to re-nest later on. And then I can clear to check if there's no collision. And then I re-nest and there is no problem at all. So I don't have any collisions there. So that you might do with a couple of parts, so that you actually change the X position so that you, in that way, influence this first layer and that you make it a bit lighter. Another solution might be to just give the part itself a slight rotation. Oh, then I need to take all parts, of course, otherwise it doesn't work here. To the part, and I need to unlock. There we are. And as said, I'll give it a slight rotation, which again will, when I renest, reduce. And I thought we had before 36% layer density at one point. So this could already be, yeah, it's 20%, so considerably lower to start with. After that, you could, of course, again, as we did before, reduce the maximum layer density, nest to density, or increase the gap distance to further improve your batch in total. But it's just a few more possibilities to actually influence those densities and improve your batch as a whole, let's say. Right. So I think that, well, there's, oh yeah, one more thing that I need to show in this demo, and then we'll mainly be listening to you. That is this configuration with the main changes here in the printers. So nowadays it's very easy to add printers here. I've had a 3 in this case. You can just add a new printer there, by which you just create the number of parts, the number of printers that you need. Although it does remain possible to save a printer as a batch. In that case, and that's definitely still useful when you're looking at with printers with no print zones, for example. And let me take this one here, the EOS, whereby you basically are going to define a no print zone as a locked part, which stays in, which is blocked so it won't move anymore, but which allows you to nest around this no built zone. So that's also still an option. You can work with those two possibilities at the same time. Right, and that concludes the demo part. At this point, I don't have a view, but I will look at my colleagues if there were any questions already. But of course, they're very welcome in the Q&A, and we'll try and get to those as soon as possible there. Let's go back to the... Sorry? Okay, one question, but I will quickly finish up this one. And then we'll definitely have some time for the Q&A. First of all, so the upcoming features, as mentioned, are mainly related to improving this cost per part, are mainly related to the gizmo that we will be adding soon, the direct MGF connection, and then hopefully soon after the direct SLS connections as well. The ComSpec connection, which is both import and export, the allowed access rotations per part and per batch. Oh yeah, there is one advanced way of even further improving your batches, which is made for high density, really high density nesting. So if you need that, contact us. Offer enormous batches. For example, we have a few parties that we're talking to, which are doing cement printing, printers of 1 by 2 meters, whereby it's, let's say, not really necessary to work with 2 millimeter voxels as we do inside AMIS. There you might want to increase that voxel size just to, well, not to wait for a couple of days for your nesting results. So if you're in either one of those cases, we're very happy to look at those options. We're also very happy to look at other file format exports that you might need for specific printers. So don't hesitate to contact us on that. Also, something I didn't mention yet, but we're now multi-color. So if you have color parts and you need to export, for example, for the HP 580, contact us because we can actually get those parts through to your printer. Sorry, I'm trying to go too fast here because I do want to have a look at those questions. We're also, of course, already preparing the next releases whereby we will have more attention mainly for this SLI export, the CLI export, so that we can have your SLS printer directly connected, not through the STL export. But we're still open to your suggestions, of course. And we've got this whole list of over 200 ideas that we still can put in AMIS Pro, or by which means we can still improve AMIS Pro. That list is for a big deal influenced by your opinion, so please do let us know. Finally, by fall next, we'll be going cloudwards. We will make sure that we really have cloud connectivity for AMIS, which doesn't need to mean that we'll be only operating in the cloud or that you won't have your off-cloud solution anymore. Not at all. We'll just make sure that the connection is there and that you can very easily make that connection online. Right. I also promised to say something on the pricing. It's still as simple as ever, 499 euros per license per month if you go for a monthly license. If you go to an annual license, that you get a 20% discount, 399 per license. And of course, there are other discounts if you go for multiple years or multi-seat orders. That's, of course, something we can discuss directly with you. And also, if you would need a specific solution for your printer, if you're a printer OEM specifically, let's discuss it. We can always have a look at what the requirements are. But we do know that in first stages, it's quite often enough to just start working with AMIS Pro and start using that as a solution before making something which is specific for your printer. So that might be a very easy way to go forward very rapidly. Good. So I'm very glad that I made it, kind of in time. I'm now trying to have a look at the where is it? Oh, there we are at the Q&A. Right. Okay. The Formlabs Fuse SLS is a first question, and I'm actually very happy with that question because the Fuse, the Formlabs Fuse is something we're definitely looking at, of course, and we do think we have added value there, but as far as I understood so far, there is no specific need for a specific output from the AMIS Pro software, meaning it would be, as I understood it, quite easy to work through a 3MF export and then import into the Formlabs Fuse by which it can be printed. So it's, of course, if there are faster or better ways, we'll be glad to look into that. But from what I understood, the 3MF solution or the 3MF export would be rather easy and speedy to basically get it into the Fuse one and get your print out. Then there's another question about Phasio. Can Phasio serve as a backlog? Yes, indeed. And so at this point, you have, let's say, two options. Either you, well, no, there's three options, and probably there are more, but there are three that I think of. Either you just have a look at your batch, you see what's in, and you're gonna manually adapt your backlog somewhere, saying like, okay, 83 of those were in, so I still have to print 17. That's the solution we all try to avoid. Secondly, you could use our AMIS Pro, whereby basically what is not inside the batch is your backlog. And we know quite a few users who just work like that. They just keep filling up the AMIS Pro software, which with whatever needs to be printed. Meaning they create the batch and they just keep on filling up as per the need and then create new batches on the go. So that's basically your backlog is kept inside AMIS Pro. But that doesn't directly connect to maybe to your MES or ERP system. And so thirdly, what you could also do is indeed through Phasio, just import export as per the need. And the Phasio import will recognize like, okay, this part 83 of them were in, so there's still 17 to be printed. So I don't need to keep that here into AMIS. I will just reload the next import from Phasio to continue working, basically. Another interesting question about the bundle AMIS and Phasio. Well, at this point, no, there is no bundle price. We think just the combination is worth a lot of money already because it goes so easy and it really helps you forward quickly. So there is in the short term no real bundle foreseen, but well, whoever posted this, you can of course contact us and we'll see where there might be a need for that. Then there is Mr. Anonymous. Absolutely great job, really exciting progress. Is custom part labels serialization in the pipeline? Well, thanks a lot for that comment. We're very happy to hear that. We're still striving to go beyond that and really become even better in this segment of additive manufacturing. So thanks a lot for that. Custom part labels serialization in the pipeline. Yes, indeed. We do have definitely because you're not the only one actually asking for this specific feature. So it's definitely in the pipeline. It's normally foreseen before Formnext, so our release version 3 should be in by then. If there's a really urgent need, contact us. We can see if and how we can shift with priorities, but please keep in mind with more and more customers coming in from any kind of software, by the way, we do have to talk to our development department before making any promises, because more and more people, more and more users means also more and more requests. So we're definitely willing to make that puzzle and to see where we can help, how much we can help to get you going as soon as possible. Oh, some more questions coming up there. Possibility of seeing multiple iterations of a nesting instead of going through the one process. I press cancel on. Multiplication. Oh, well, the iterations go automatically, of course. The best way to actually interrupt that process would be, for example, and it's still shared here, I think. No, would be, for example, to here set the nest to density and make that yeah quite low, so that it will stop the first time really after the first iteration and allows you to go beyond that with each step. So that would very easily allow you to go step by step, let's say in those iterations. Oh, and then I did miss a few parts. Custom part coloring. Um, No, that's okay. Yeah, I understand it. It's again the question of Mr. Anonymous at 524. Custom part coloring, we didn't foresee that yet. No, it's definitely an interesting one, and I know it's sometimes being done. So one to write down, and we'll put it on our list, and please do get in touch to discuss how important this is to you. One last question there I see. Bamboo slicer allows creating multiple beds at once, if not all parts fit in a single build. Do you think that will be possible in the long term? Again, great job. Look forward to seeing more. Thanks for that. Well, yes and no. It AMIS Pro doesn't really allow to create multiple beds at once in the same environment, but you can just open AMIS Pro multiple times. And basically I can just show you that while we're working on it. All right. Right. So now I have, oh, let's just create a new batch here, create. So as you can see, there is one open here and the other one is open here. Voila. So it is possible to just work with two batches next to each other and continue working like that. Well, and that's all the current questions there are. I don't know. I will wait here for another few seconds to see if any new questions are coming in. But apart from that, I would like to thank, well, first of all, the colleagues for helping me out here as usual, and for making all this, by the way, as well. And definitely you for attending, whether you're already a user, thank you for using AMIS Pro, or whether you're a future user, thank you for being here. Thank you for attending. If there's anything we can do for you, we would be so glad to know and to get into that discussion together with you. Thanks again. No further questions, it seems. So we hope to be in touch. Please don't hesitate to contact us in that regard. Have a nice day. Bye.